All right. Hi, and welcome to our first day of C and Software Tools class. We're having to meet distributed because our class is a little on the large side, and with the extra spacing requirements, there's no classroom that's big enough for all of us. But I'm hoping, let me know, I'm hoping you can see the first slide in our batch of slides. Somebody just unmute yourself and say something if I made a mistake.
We're good.
Yeah.
And in fact, in general, my plan for asking questions for the class is when lecture's just going along smoothly, just keep yourself muted so that you don't get embarrassed by someone walking into the room and saying something or something like that. But if you want to ask a question, just unmute yourself and go ahead and speak out loud and interrupt me. That's okay. Also, if you put something on the chat, I'll check that, but I usually don't get around to checking that until the very end of class. I don't mind you putting stuff there, and sometimes other students will answer each other, and that's okay. I just, I don't have enough screens to keep up with all of that at once. So you're free to use the chat session, but if you really want to ask a question or something, I don't mind being interrupted, and I would say just do that, just unmute yourself and ask that, and that would be easiest for me. So we've got a couple of things that I want to do here on our first day. We're going to go through administrative details about the class. I'm hoping to keep that short. And then we'll start learning some C++. We'll talk about how, sorry, I'm hesitating because I see that I didn't update this slide yet. I must have updated the one for my other section of the class. So I'll look at this slide, but I'll make sure it's updated and that the updated version is posted. Sorry, I'm hesitating because I realize what I did wrong for updating this. My Microsoft products stopped working, so I'm having to use LibreOffice, and I saved this, but I didn't overwrite the Microsoft version of this, the PowerPoint slide of this, so that's why it's not updated. But let's pretend this is going well at this point. So I was going to introduce myself. I'm David Sturgill. I've taught this class for several semesters. I've got some contact information for myself there. I've got office hours, but that's part of what didn't get updated when I updated this before class, or I didn't save it to the right file name. I've got a Monday and Wednesday office hour, but instead of 2 to 4, I've got 12:30 to 2:30. Up near the top of our Moodle page, there's a link that shows my actual office hours along with everyone else on the teaching staff, and that's accurate. And I'll sneak in and update. In fact, I may have already updated the version that's posted to our Moodle site. Another mistake or another thing that hasn't been updated is the instructor. We're in section 1. The instructor for the other section, section 2, is Dr. Susan Balick. We have 3 sections of the class going on right now. Section 1, the one you're meeting now. Section 2, which would normally be another on-campus section, and then a small off-campus section. And we'll all be going through some of the same material at about the same pace all semester. Here are our teaching assistants, but that also didn't get updated or didn't get saved. Hannah Chipman is still a teaching assistant for the class. We have 2 other teaching assistants. We have one named Nick, and we have one named Peng Cheng, both of them who have helped out with the class in the past. Utsab did a great job last semester, but he's not TAing with us this semester. So like I said, I'll make sure the posted version of this is correct. All of our TAs have office hours. So these are not just people who will be grading your work, they're people that you'll be able to visit to get help if you're having trouble with an assignment this semester. So I apologize, this slide is out of date. For this class, one of our main resources that I'll depend on is our Moodle page. In fact, you've probably already been there because to get the link for this Zoom session or to watch a recorded version of this video, you probably got to that from a link from our Moodle page. Our Moodle page is going to have a lot of resources. It'll have slides and recorded lectures for all of our lectures. Most of the stuff that you submit, like homework assignments and exercises, you'll download those from Moodle, and many of them you'll submit through Moodle. I'll be posting grades on Moodle as we grade your materials. And as we take exams this semester, all of that will be done through Moodle. We're also going to be using Piazza this semester. Many computer scientists have used that in the past, so I think you're probably familiar with it. We'll use that for online discussions, and mostly for me, I'll use it for a lot of announcements. So every week, as I'm reminding you of the stuff that's due, I'll send out Piazza announcements about that. So make sure you opt in on Piazza if you haven't done that already. In addition to using Moodle and Piazza, once we get into the semester a little bit, instead of submitting our larger projects using Moodle, we'll use NCSU's GitHub for that. Probably the same kind of thing that you've done in some of your previous classes. Questions? We've got more administrative stuff to talk about. I'll talk in more detail about online exercises and quizzes and projects and things like that. Questions before we move on a little bit?
Is this going to be nearly as emotionally taxing as 216?
I've never taught 216, so I don't know that. But I know 216 has a reputation for giving you a lot of chances to practice the material you're learning. I think some of the projects in this class are challenging. I think as a whole, it's probably not going to be as challenging as 216. But again, having never worked with that class, I'm probably not a good source of an opinion. Other questions? All right. What are we going to learn in this class? Well, we're learning, for many of you, we're treating this as if you're learning your second programming language. You're already good Java programmers. But we're going to learn another language, one that forces us to get by without object orientation, to work with designing programs with procedures, kind of an older style of language. A nice thing about this is it'll help us get closer to the hardware. We'll be able to see more clearly how our programs work, and it'll give us good reasons for working directly with some of the programming tools, often ones that have been hidden inside integrated development environments that you may have used in the past. We'll use some of those things directly this semester. We assume that you've taken 216 class, and that means you not only know the building blocks of any decent programming language, but you know some data structures and algorithms that you might use. And we'll depend on you already knowing that for this. So if I say something like, this is an implementation of Quicksort, I kind of count on you already knowing what Quicksort is, for example. I mentioned, and this is another slide that didn't get updated when I saved the slides. So the stuff down at the bottom is inaccurate. I'll make sure it's accurate on our website. What are we going to do in this class? We'll get to do a lot of programming in this new lower level language. Well, new to us, C. We'll get to use a lot of tools that work with that. As far as what you get to do to earn your grade, you'll get to take a quiz for about every day of lecture. That'll be an online quiz this semester. You'll get to do a small programming exercise, or usually it's a programming exercise for about every day of lecture. You'll also get to do about 6 larger programming projects, and the first of those is already posted on our website. You'll get to take 2 preliminary exams, and those are the dates left over from last semester. The syllabus should have the correct dates for those. They're at about the 1/3 and 2/3 part of the semester. And then a comprehensive final exam that's scheduled by the university. That date is left over from last semester, but the syllabus should have the correct one. For all of these, we'll have a window of about 24 hours for taking the exam. So you don't have to take it during the standard class time, but you'll have, well, I said 24 hours, I guess more accurately about 9 hours, about the start of the day, about 8 in the morning until 5 in the afternoon to take that exam. I mentioned the various places your grade's going to come from. Here are the weights for those. So those out of class quizzes and exercises are going to add up to 8% of your grade each. The larger programming projects will be 40%. The 2 preliminary exams will be 12% each, and your final exam, your comprehensive final, will be 20%. I got a table here. It's the standard table for how your final average computed via these weights, how that determines a letter grade. I don't do any rounding or anything with those letter grades. So if you get 63 or greater, then you get a D. I should have picked a more positive example. If you get an 87 or greater, then you're going to get a B plus. If you're close to the cutoff for a grade, I usually go trying to look for a reason to bump you up, but I don't deliberately do any rounding of the grades because I feel like I don't need to on that. I'll spend a couple of moments talking about, in general, what we're going to learn and talking about some of those categories of grading that I just mentioned, like exercises and quizzes. We have a required textbook for this class. It's the second edition of King, C Programming, A Modern Approach. One thing I like about this textbook, I've got a copy of it right here. I don't know if you can see me in my little picture, but here's a copy of the textbook. It's several hundred pages thick. A nice thing about it is it covers both the older standards of the language and the slightly newer C99 standard. Some of those lots of textbooks favor the older, kind of more basic versions of C, but I like using some of those new features. I think it makes the language a lot easier to work with. So I like a textbook that has built-in support for that. So this one supports both the older version of the language and the newer one that we're going to be focusing on this semester. What are we going to learn? We'll learn the stuff you'd normally learn for working with a new programming language. We'll learn types, how to write statements and expressions, and how to do some things that you didn't have to do as much when you were just programming in Java. How to allocate and manage memory on our own, and how to work with and debug programs directly without using tools ourselves rather than having them all hidden inside an integrated development environment. At the very end of the semester, we'll spend a couple of days trying to learn as much C++ as we can. If you use the things from C that we're learning this semester, you'll probably appreciate being able to take advantage of some of those newer features offered in the C++ language. So I'll try and give you as much as I can of that to help you feel like you can take advantage of that. If you look at our syllabus, in Moodle, down at the bottom, it lists a schedule of topics along with readings from the textbook. So that can help you keep up with the reading material as we go through it. I mentioned this already. We're going to have 2 preliminary exams that are at about the 1/3 and 2/3 part of the semester. And a final exam that's comprehensive, that's weighted a little more heavily than the preliminary exams. That's at a time chosen by the university, the final exam. For each of these exams, you'll be taking the exam electronically, but for the expectations, you won't be using any other electronic resources besides just the web interface you use to take the exam. You're not allowed to use class notes or the textbooks or anything like that. You're not allowed to ask your friends questions during the exam. I'll remind you of these rules as we get closer to the exam, but you are allowed to make a note card, a 3x5-inch note card for any of the material that you're worried you may not remember out of your own head for the exam. This is what we normally do when we're taking the exam in class. And I'm just trying to convert that policy to something that makes sense when we have to take our exams online. Again, a couple of slides ago, I had dates for the exam that were not updated, but the ones on the syllabus should be accurate for this semester. Go ahead and take a look at those dates and make sure you don't schedule anything conflicting for that. So don't schedule any job interviews or anything like that during those dates, because the dates we've planned ahead for the exam, those are the dates that we expect to stick with. Questions?
Do you plan on making the quizzes about whatever you covered during the lecture, or is it something that's going to be outside of the lecture?
That's my next slide. So we can talk about that. There's a lot of activity on chat. Do I need to look at that right now?
No. Well, one question is are the exams on Lockdown Browser?
I do not plan on doing Lockdown Browser on that. So I am trying. So my understanding is that Lockdown Browser would try to keep you from using other resources.
Yeah.
I don't know if I can win that fight if I try to fight that fight. So my hope is that I'll tell you what's expected and what's, what would be considered an academic integrity violation. And then to an extent, I'm trusting you to follow those rules when you're taking the exam. I'm not going to try anything, at least I don't plan on trying anything too extraordinary to police that. Any other questions that people want to ask out loud? It's fine to have some conversation on chat. I'm just getting a little nervous every time I see we're up to 50 some posts already, which is way more than I'm accustomed to.
As someone I've been typing since 4th grade, my handwriting is awful. So I don't think I'm going to even be able to fit my notes on one note card.
Yeah, I was going to ask, can I laser etch my note card and bring a magnifying glass?
You can, so it's expected to be handwritten.
What if it's handwritten and imposed via the laser?
So I'm going to say I expect it to be handwritten. Students vary a lot on how much they put on that note card. I had a couple of them down here on my desk. I would show them to you just so you can see. But for most students, there's not that much that they feel like they need notes for. By this time, most of that stuff will be in your head. So I would say don't think about trying to put a whole semester's worth of information on a card. Just put the stuff that you think you might need a reminder on. I even saw a student who on their note card, they put, "You got this." And that's all they put on it, which is great because I collect the note cards at the end, at least for a regular exam. So it was, I feel like that was kind of for them and for me.
Are you going to want to see our note cards?
I don't feel like I have a good way of getting them. Like I'm not going to be watching you on video while you take the exam. So I expect you to have a 3" by 5" note card that's handwritten by you. But I'm not going to ask to see it or to have a scan of it or anything like that. At least I don't plan on it. Other questions?
Yes, doctor. So, is the exam on the class time or you open for a 24-hour window?
I mentioned that a moment ago. It's I'm planning to do 8 a.m. to 5 p.m. So
Okay.
much broader than the regular class time. But not a whole 24-hour window.
Okay.
I find that having a longer window creates some problems because then, if people if Moodle goes down, which it did last semester for me, then anyone who is going to take the exam during that, they can't take the exam or they have to take it later. So having a narrower window also makes it easier for me to be there to answer questions if people have it. So I hope that a 9-hour 8 to 5 window will work for everyone. If you're in a different time zone, keep that in mind. Other questions? All right, I appreciate all the questions. All right, I mentioned about every day you'll have an online quiz. Normally this would be something we'd take at the end of class on paper, but we're doing it online in Moodle. And I think your first quiz is already posted. All of these quizzes are due at 11 p.m. on Sunday evening. And that kind of means some stuff can pile up at 11 p.m. It's nice that you only have one time to remember for that. But I would say don't plan on doing all the stuff that's due within the last hour before it's due, or you might run out of time. So I'd do your quizzes. My plan is after you've watched the lecture for a given day, I would go ahead and take the quiz and then be done with it. And then it'll be doing its job. Its job is to see how well you understood the material. The quizzes tend to be between 8 and 10 multiple choice questions. And I hope that this is an easy part of your grade. One thing that helps with that is at the end of the semester, I drop your 3 lowest quizzes. And then even from what remains, I drop some of that, or if you miss some points on some quizzes, I drop a fraction of that grade. If you need a description of what it means to drop a fraction of that grade, it's described in the syllabus. So essentially I drop 5% worth of zeros off your remaining quiz grade if you missed any points on that. You'll also have daily exercises, which are similar. They're due on, these are programming exercises. So usually you're writing a little program that you'll turn in on Moodle. Same time, 11 o'clock on Sunday evening. So if we have 2 lectures each week, then on a typical Sunday evening, you might have 2 quizzes that you have to complete and 2 exercises that you have to do. And the exercise for today should already be posted. Same dropping policy as the quizzes. So if you forget to submit an exercise or 2, or if you're sick, or if for any reason you can't submit it, you get 3 dropped ones before we have to start worrying about, I guess if you had a protracted illness, we could drop more than 3 of those. The exercises are small programming problems. The projects are the larger ones. So during the semester, we have 6 projects where you get to solve bigger problems. You might be writing programs that are a few hundred lines of code in C. These are initially, our first one's already posted. You'll get to write or edit a few small programs and submit them on Moodle. And after the first one, we'll submit these using NCSU's GitHub. We don't have a late submission policy for exercises or for quizzes, but we do for programming projects. So for these, you can generally submit 24 hours late if you need to, but it'll cost you 20% of your grade. So if you can submit on time, that's always a good idea. It gives you a chance to keep more of your points. But if there's some critical mistake that you need a little more time to fix, this gives you a little bit of a soft deadline for projects. I got one more aspect of my grading. Even with a late policy on projects, I find that things still go wrong. Students sometimes forget to submit something, or they accidentally submit the wrong file or the wrong version of a file. So I have what's called my sympathy folder for each student. This is a way of collecting work that we can't grade normally, so I can take it into account at the end of the semester. If there's a project or an exercise, probably an exercise and you just forget to submit, but you did the exercise, you can wrap it up in an email. So this is my plan for how this works. Wrap up whatever you couldn't submit or whatever you made a mistake on submitting in an email with a short explanation of what happened. And I'll save it along with your note until the end of the semester. And then if it ends up mattering, like if that made the difference between an A and an A+, or a C and a C+, I'll take a look at it, and that can give me a reason for bumping you up to the next grade if if you would have done well on that. So again, just send me an email, send it to me, not to the TAs. And again, I'll send you a response and I'll save that until the end of the semester. And I call that your sympathy folder, something I can take into account at the end of the semester. Other questions?
Yes, are those quizzes are like a time quiz or non-time quiz?
The quizzes are not timed.
Okay.
So my plan is they are intended to be closed book. So you watch the lecture, you try to make sure you understand everything, and then you take the quiz to see how well you understood it, see how well you understood the material. But there's not a timer running while you're taking the quiz. The exams are on a timer. They're still online through Moodle, but the quizzes are not on a timer. Other questions?
What kind of help can we get during office hours? Is it just project help, or is it like?
You can get any kind of help during office hours. If it's an administrative thing, you might want to make sure you come to my office hour, because I can, like if some grade didn't get recorded correctly, I can probably fix some things that TAs may not be able to fix. But if you just need help on an exercise or a project, you can go to any of the teaching staff, either for this section or for any other section. So all sections of the class are working on we're going through the same lecture material at about the same pace. We're doing the same exercises and projects, so anyone ought to be able to help you out. I laughed a moment ago because you can even use the office hours to remind me of things. So if you send me an email saying, hey, why don't you do this thing for me? And you don't get a response in a timely manner, I would say show up for office hours and say, hey, how's that email going? And that'll help make sure that I don't miss something important that you need me to take a look at. Did I answer your question, or let me know if I didn't?
Yeah, that answered it.
Other questions? All right. We'll mention this some more later, but we have a style guide for this class. It's already posted. And those are just rules that you're expected to follow when you're writing solutions to the projects. Things like where curly brackets go and how you're going to write your comments and what needs to go in the comments. The style guide only applies to the projects, only to those big programming things. It doesn't apply to the small stuff, the exercises. Those, I should have mentioned this before, those are automatically graded. I've written a little grading script for each of those. So it's not smart enough to check style, but that also means it's not smart enough to recognize when your output is almost right. So on the exercises, you'll want to make sure that if your program works and prints the right output, that it prints exactly the right output, not anything that's close to the right output. But on the projects, on the bigger stuff, we will be checking style in addition to just making sure your code works correctly. I mentioned some of this already for communication. The best way for me sending information to you is our website in Moodle. Best way for me making announcements and for you getting help from each other and from the TAs is through Piazza. And the best way to talk to someone interactively is through the office hours. Every TA and instructor for the class has a few office hours every week, and we try to spread those around. We haven't decided what they're going to be for everyone yet, but mine are already posted, and we'll have those posted for the TAs soon. I don't know if you care about this. This is other stuff about me that may or may not matter to you. I've been teaching at NC State for almost 10 years now. I got my PhD from Cornell about 25 years ago, and I spent about almost 15 years at Baylor University in Texas teaching computer science before I came here. Outside class, I teach other classes. I teach the operating systems class normally. This semester, I'm teaching the assembly language class. So both of those are classes you might normally take after this one. Usually I teach the senior design class, but I'm not teaching it this semester. I'm the coach of the competitive programming teams here at NC State. So that's for people who like to try to hack together solutions to programming problems fast and do it faster than other competitors trying to do the same thing. We have a weekly, we're going to compete in a couple of contests this semester, even though it's all going to be online. We have a Tuesday evening meeting, which is open to everyone. If you want to join us for that, there's also a 1 credit hour class that you can take if you're interested in that. I listed some other things here. This is another part of my slides that didn't get updated. I got a daughter who's taking computer science. She's about to graduate, but she's going through much of what you're going through as a computer scientist. I'm also a runner and a trombone player, and I can ride a unicycle. And I've got a pet parrot. There's his picture there. So if you have any of those common interests, we can talk about it after class if you want. How to enjoy and do well in this class? I would say try to keep up. The regular exercises and quizzes are intended to help you keep up with the lectures. If you plan on watching all the lectures the night before an exam, it's probably going to hurt your exam performance. So keeping up and getting started early on class will help. It says come to class here. I know that doesn't apply too much this semester, but if you can, forcing yourself to be present for the live lectures will probably help you catch up or keep up with the material better and help you feel like you're plugged into the class. So I'm not going to try to make you do that. You can watch the recordings if you want, but it'll probably help you if you can be present for the live lectures if you're able to. And take advantage of your available resources. I listed some of these there. I feel like often office hours, for instance, are underutilized. So if you can get started early on a project and you run into trouble, visiting office hours early can be a great way to try to get yourself past some difficulty. That's all the introduction for the class I've got. I hope I didn't miss anything too important. Questions, or were there any technical problems while we were going through that?
What's your parrot's name? A lot of
I
people in the
can't tell
chat
you.
were asking.
I'd like to tell you, but that sounds like one of those questions that they ask you when they're trying to tell you your bank PIN or something. So it sounds too risky to tell you.
That's fair.
He does have a name and he can say his name. And that's one of the things he likes to say.
I'll ask a less personal question. What's your CCV on the back of your card?
I don't know, not off the top of my, give me a moment to check. Other questions?
Can we see the parrot?
You saw his, I'll work on it, not right now, because then we'd have to go through the whole house to see him. If you listen, you might hear him occasionally.
Do you have a parrot?
It's on my slide.
Oh,
I've got a question. For the quiz that's for this weekend, is it like on the slides that are on Moodle and activities on there and stuff like that, or what?
It
What
should
we
already be
expect
on
for that?
Moodle.
It's already on Moodle.
Yeah, so our page on Moodle is kind of organized by lecture. So there's some administrative stuff at the top, but if you scroll down a little bit, it'll say like day one or in probably the subject for day one. And there
Okay.
should be a link for submitting the first exercise and a link for taking the first quiz.
So there will be like content for that quiz, like, because we didn't really go over like a ton
We're
of
not
content
done.
here. Oh, we're not done. Okay, my bad. My bad.
Sorry, that was just the administrative stuff.
Okay.
So I am sitting on the edge of, all right, let's talk about C. So yeah, we'll learn some content. And that's what our next batch of slides is. Other questions before we do this? All right, so normally in lecture I say, all right, enough administrative stuff. Let's talk about what we came here to learn. Let's talk about the C programming language, and let's see how much we can cover today. We're gonna try to get an overview of the language. We'll take a look at some programming tools. We'll learn how to compile a C program. And then I'll try to, and here I'm cheating a little bit, but I'll try to convince you that you already know a huge amount of the C programming language because they stole it when they were writing languages like Java. I'm not mad about that. I think it's great. It means when I learned Java, I didn't have to learn a whole lot of new stuff because they borrowed a lot of the ideas from languages that I already knew. You want to learn C. There will be times when it's painful, but there's a lot that you can do if you know a language like C that you can't really do if you're stuck in higher level languages. C will let you write higher performing code, faster code, even if you're programming in a higher level language, because you understand what's going on underneath. It'll let you, it will let you understand more about what's going on closer to the hardware, which can pay off in your subsequent classes, like the operating systems class or the assembly language class, both of which I've had a chance to work with. Even if you didn't want to program in C, somebody's got to be able to program in C because so much of the infrastructure we depend on is implemented in lower level languages like that. So that operating system running on the laptop in front of you is probably written in C, or at least in large part in a language like C. If you're accustomed to programming in Java or similar languages that run on something like a JVM, that JVM itself is probably written in, I mean, it is written in lower level languages, including assembly, C, and C++. And a lot of special purpose applications like building embedded systems or high performance applications benefit a lot from C because C programs can be really, really small, and the development tools you need for writing in a language like C can be really, really small and low overhead. So even if we didn't spend our careers programming in C, we certainly depend on people who are experts in languages like that. As a computer scientist, I feel like you need to be able to think at all those different levels. So even if you're programming in a higher level language, occasionally you need to be able to drop down and think about lower level languages just to understand what's going on at the higher level. I already mentioned programming in C will help us think like a different type of programmer. In Java, well, C is like Java in that they're both imperative languages. When you write a program, the instructions you write are telling the computer what to do. They're saying how a computation should be performed. The statements say things like do this and then do this. So they're both imperative languages, but the building blocks are a little bit different. In Java, the big things you work with are objects or classes. So it's called an object-oriented language. In C, we don't really have objects. At least we don't have language support for things like objects. The biggest things we have to work with are procedures, or what we'd probably call methods in Java. So designing a big project is really a matter of deciding what procedures we need and how they're going to work with each other. If you think of Java and C, they are a little bit different, but not that different from each other. This distinction between procedural and object-oriented is probably the biggest distinction you'll see. Learning languages, we could have gone much further from Java if we wanted. We could have learned something like a declarative language instead of an imperative one. Whereas imperative languages say exactly how a computation should be performed, declarative languages try to leave that out. They try to let the programmer describe what should be computed without making a commitment to exactly how it should be computed. And this can be a better, maybe even an easier model to program in. I've listed here some particular models we could have looked at, like functional languages or data flow languages or logic and constraint-based languages. Well, it's not for computing, but even HTML is a declarative way of describing a document, of saying what goes in the document through markup. We didn't get, even though C has been around for a while, we didn't get there right away. We went through several languages. So I've kind of listed here the evolution of C, or at least the development of C from some of its predecessor languages. Of all of those earlier ones, C is probably the one that got used and continues to get used the most. Language development didn't stop at C. Some languages that you use and that you've heard of borrowed a lot of ideas from C. So languages like Perl and C++ and Java and C# borrow a lot of ideas from the language C. And you're going to notice that when we start looking at C syntax, you'll hear me say over and over again, this is a lot like blah, blah, blah in Java. I think that's going to make it a lot faster for us to get started in a language like C. In C, as languages mature, we add features to them. Languages tend to change from year to year. When we're meeting in person, I usually show some books that describe sort of the evolution of C. Originally, the C programming language was described by the book I've got pictured there, the Kernighan and Ritchie C programming language book. And it is a thin little book. At the time, it didn't take very much text to describe how the C programming language is supposed to work. So if you look at it on Edge, it's just, I guess, a couple of hundred pages thick. If you compare that to our own textbook, the language has grown up a lot since then. For about the first 10 years of using C, it had an informal standard that was described by that book. And since then, in '89, it was standardized. People got together and agreed on what it meant to write a program or to support a program in the C programming language. And then again, in 1999, the standard was extended to include some new language features. That's called the C99 standard. I put that one in red because that's the one that we're going to be targeting this semester. So the version of the language I expect you to understand and be good at is the C99 standard. C didn't stop there. It's continued to develop, or people have continued to extend and refine it. There's a C11 standard that was developed in 2011, and the extension of the language has continued even since then. But we'll be targeting that earlier standard, C99. It's new enough that it has some nice features that weren't originally there, but it's old enough that it's easy-ish for us to get a textbook that supports that. You can think of C as being just a little bit extra on top of the underlying machine language supported by your hardware. So think of it as a thin veneer on top of your underlying assembly language. It lets you get a lot of the performance advantages of programming directly for the microprocessor, but without the tedium of having to write in a particular machine's instruction set. Because it's kind of made to be close to the underlying hardware. There are some parts of the language that are unspecified by the standard. What do I mean by that? Well, if you think about Java, in Java, you know exactly the capacity of something like an integer. There are parts of programs where you can say, well, this is exactly what it should do if you compile it using the Java compiler and run it on a JVM. And in C, there are bigger parts of the language that are unspecified, where they say, well, this is up to the compiler developer, or this may depend on the system you're running on. Things like the size of an integer. On the system we're going to be using, an integer has exactly the same capacity you're used to from Java. But that's not guaranteed to be true on every system. So since C programs can vary in how they behave from system to system, it's more important that we kind of agree on what system we're going to develop on. That's one reason we'll talk about the common platform in a moment. We have to kind of agree on, when you submit a program and we test it, what machines are we going to compile and test it on, so that you can know what you're going to get. You can know what you need to try out when you're developing. One nice thing about C is, because it's a little closer to the hardware and it takes advantage of some details about the underlying hardware, C programs can be a lot faster than they would be in a language like Java. And I wrote some examples to show this off. My first example, normally I would show this at a terminal window, but I think we'll take a look at this a little bit later. But I wrote a program called nothing.java. I think it's already posted on our website. And if you look at it, it's just an empty main method. If you compile and run that in Java, at least when I did it, it took about 1/10 of a second to run. I wrote the same thing in C, just an empty main in C. So it's programmed just like the Java program. It doesn't do anything. But if I compile and run that, it runs almost 100 times faster than the Java program. Now, maybe that's an unfair comparison, because to run a Java program, you got to start up a big old JVM and you got to load in the class file for that program before you can even start running it. But in C, you don't have to do any of that stuff. Once a program has been compiled, it's ready to run on the target architecture, which means the overhead for starting up a new program can be much smaller than it is in Java. And that's really what we're seeing here. Admittedly, this is showing that C is a lot better than Java at doing nothing. But it's also a lot better at Java, at least potentially a lot faster at doing some useful things. I wrote a program that sorts a list of words, and I tried it out on a list of 60,000 random words that I made up. And in Java, it took about 1.5 seconds to do that. In C, it took less. A similar program took less than 1/10 of a second. So here, about 24 times faster. I wrote a program that does matrix multiplication, and in Java, it took about 3.5 seconds. In C, it took a little over 0.5 second. So here, about 6 times faster, just multiply these large-ish matrices. And this is one of the reasons you might choose to write some of your code in a language like C. Because you're programming a lot closer to the hardware, your programs can be a lot more efficient. They can run a lot faster. There are a lot of disadvantages to using C. That thing we just talked about having some things that are not specified by the standard, means portability can be harder. Programs can behave slightly differently from one system to another, or from one compiler to another. Because the execution environment is doing a lot less for you, it means you have to do more yourself as the programmer. And it means that The language provides a lot less in terms of protection and security. If your program wants, or if a PC or program wants to do something bad, if it wants to mess with part of memory that it shouldn't, there's not a whole lot to keep it from doing that. Also, we'll see a little bit of this. C doesn't really have mechanisms for managing really large development projects, ones with maybe hundreds of programmers working together. And for newer languages like Java, they've added a lot of features for that. We'll miss those when we're having to program in a language like C. In this class, we'll not just learn about a new programming language, at least new to us, C. We'll also learn how to directly use some software development tools. These are things you've used before, but they've often been, and I've said this a couple of times, they've been hidden in your IDE. So you've used things like debuggers or maybe profilers or editors, but you've used them as part of a bigger software development system. The plan this semester is to get some experience using those things directly ourselves, because sometimes you have to do that to solve problems as you're writing and debugging programs. I mentioned that a language like C, because it's lower level, the behavior you get from a program might depend some on the system you run it on and the compiler that you use. So it means when we're grading your work, we have to agree on, well, this is the system we're going to target. And we've picked a system that we call the common platform. That just means that's the system that we're going to agree that your programs need to run on. And when we test them, that's what we're going to test them on. This is, for us, a readily available system. The common platform is just our name for a system running the university's installation of Linux using the GCC compiler suite, the GNU compiler suite, running on a 64-bit Intel PC. So I know most of you are not on campus. Well, many of you are probably not on campus, but if you are, if you walk into a lab of Linux machines, those are the machines that are available. If you remotely log in to one of the machines at remote eos.ncsu.edu, you're getting to one of the machines that we'd call a common platform machine. Because of this, you've got some choices for how you can develop and test your code this semester. And I've listed some of these in this table. I won't go through all of these, but we can talk briefly about kind of what some of your alternatives are and some things to keep in mind. If you're on campus and you can go to a Unix or a Linux computer lab, you'll be sitting down in front, at least you can be sitting down in front of a common platform machine. That's kind of a nice environment because you'll have access to all your AFS files and you can run graphical programs. You'll have access to a graphical user interface, which can give you more choices for how to use editors. If you're not on campus and you want to use a university Linux machine, you can remotely log in. So you can run SSH to remote Linux eos.ncsu.edu, and that'll at least give you a terminal prompt on a similar machine. It won't let you run graphical programs. Secretly, you can run them if you're willing to tunnel X11 connections. But if you're connecting from off campus, it'll probably be slow to run programs like that. Alternatively, you can fire up an image at VCL and get access to a remote common platform machine with some of the same advantages as using that remote Linux login. But those are ways that let you use a common platform machine. But if you're not on campus, what are your choices? Well, I listed some others at the bottom. If you're on a Macintosh, the developer tools will behave a lot like the GCC compiler suite. If you're on a Windows machine, you can use Windows Subsystem for Linux as a way of developing and running your code in a Linux environment. You can use a virtual machine image on your Linux machine and develop on that. That's what I actually do when I'm developing stuff for this class. And I've posted a ready-made Linux machine if you want to try that out. It's also easy to make one for yourself that'll run on a virtual machine. If you look up at the top of our Moodle page, I got a list of about 5 different ways you can do exercise 1 using various technologies like this. If you're not accustomed to remotely logging into a Linux machine and writing and running your code, you could try a couple of those techniques that I've listed up there and see which one looks like it works out well for you. If you use any of these methods at the bottom, that's a fine way to develop and even debug your code. But if you're running, say, on a Mac OS machine using their developers tools, that's not really a common platform machine, and you're gonna see some differences. Even if you're using a Linux machine or Windows subsystem for Linux, it may not be exactly like what we have on campus. So the compiler may behave a little bit differently or generate code that's a little bit different. So if you develop on any of those systems that I've listed in gray there at the bottom, before you turn in your work, I would try it out on a real Linux, NCSU Linux machine, just to make sure there aren't any unpleasant surprises before you submit. So if you develop on, say, your own VM running Linux, it's probably worth it to upload your solution to a university, maybe to a remote Linux machine, and try it out there before you turn it in, again, to make sure it behaves there the same way it does when you were developing it. Like I said, up at the top of our Moodle page, I've got a list of a few different ways you could do exercise 1. I would try out a few of those until you find one that you like. And then if you find a technique that works for you, you can use that on previous exercises and projects. Questions before we move on?
Do you recommend us to just go through, so I have a Mac, do you just recommend us to just go through the terminal and just use the remote client instead so that our work, because you said you're going to be grading based on the common platform.
I don't necessarily have a recommendation on that. I guess if it was me, like for how I would develop, I wouldn't do all of my development on remote Linux. If I did, I would either have a slow connection or I would have to do everything in a terminal window. For me, I would rather develop locally, so I could either use the Mac OS development tools, or the way I really do it is I have a Linux virtual machine running on my laptop, and then I do all my development there. But before I post a new project, I try to make sure I try it out on a university Linux machine. So I upload it to remote EOS ncsu.edu. I compile and run it in there and make sure it behaves the same as what I was getting locally. The nice thing about using a local VM is you can easily have a Linux machine running on your laptop, so you get good performance. But there's always the possibility that because it's probably not the same installation they're using on campus, you may get different behavior from your compiler. Usually that different behavior only shows up when you have a bug in your code. But it's common to maybe have a solution that's got a bug in it, and if you don't see that bug on your own laptop when you're developing, you might accidentally submit code that has a bug in it that you didn't know about.
Gotcha. Thank you.
Other questions?
Does this course use Jenkins? And if so, if it compiles on Jenkins, does that mean that we're good to go?
Not necessarily good to go, but if it compiles on Jenkins, that should be running on the same kind of machine we're going to test it on. We don't use Jenkins for the exercises, so you'll need to worry about that yourself. And on the projects, we usually add some extra test cases that we don't provide. So even if you're passing all the test cases on Jenkins, you could still miss some of those extra test cases we added. Usually, like when we're grading a project, I go in and make up some additional test cases, and usually they are, I might make up a larger test case to try a project on, or I might make up a additional error test that is there in the description of the project, but maybe we didn't cover that with one of our test cases. So I would say that's worth thinking about before you finish up a project, to think about, well, is there anything that we didn't cover in the test cases we gave you?
Thank you.
But yeah, the intent is the Jenkins machine should be running your solution on the same environment we're going to test it on. And if we grade your solution and it was passing on Jenkins, and then we grade it and it fails all the tests, that's something that it's worth asking about afterward. That may represent, I mean, sometimes that could be something that went wrong when we were grading that we could fix. So we don't mean to catch you by surprise on that. If you're passing all the tests on Jenkins and then you failed all the tests when we graded it, I would talk to us about that so we can figure out what went wrong. Other questions?
So we'll be using Jenkins on all the projects, correct?
Not the first one, because I don't have it set up. We don't normally use it for the first one, so you're expected to test yourself on the first one. But starting on project 2, we should have that Jenkins system available. But we'll also give you a test script so you can test those yourself. Other questions? All right, I already switched the slide here. In the time we have left, about 15 minutes, I'm hoping we can see how much C we can learn. I've got here the traditional Hello World program in C, and I want to go through this real fast and tell you what you're looking at, learn a little bit of C, and then make comparisons between C and Java. So this is a program in C that prints out Hello World. Let's give it a try. And this is, I was trying to prepare this right before class, and I ran out of time. So I need to go get, I apologize that I'm not ready for this part. I need to go get a copy of that source program, class. Sorry. All right, so first, so here I'm just running in a terminal window. I'm just running this on my local laptop, which is a Macintosh machine. So it's not really a common platform machine. I could remotely log in to a Linux machine on campus. I just didn't get ready to do that right before class. So I don't want to take time doing that right now. But this terminal environment is a lot like what you'd get if you logged in remotely to a university Linux machine using PuTTY or using MobaXterm or something like that. The program that we were just looking at is hello.c, and I'm going to bring it up here in an editor. I'm going to use VI, or it's really, nowadays it's the same thing as Vim. That's just a basic text editor that will run in your terminal. I can get around in Vim. I'm okay using it to edit code, but I'm not great in it. So I don't normally, it's an easy way to take a quick look at a file, but I don't usually use that to actually write very much code myself. But this is the same code we were looking at in a slide a moment ago. You can see this is the part that actually prints the hello world. I wanted to show you this code right now, but instead of looking at it in a text editor, so if you're in Vim, or if you ever get stuck in Vim, typing :Q and then hitting enter should exit it for you. I want to build and run this program. So for a C program, we have to compile it, kind of like you have to run code through the Java compiler before you run the Java program. And using the same instruction we just saw on our slide, GCC is the name of the GNU C compiler. That's the command to run to compile a C program. At least it's the one we're going to use. And we're almost always going to use this -big W little ALL option. That enables a big pile of warnings in the compiler. So it gets the compiler to complain about things it doesn't like. For us, since we're just learning a language, that could help to detect errors in our program. I also mentioned we're targeting the C99 standard of the language, and that's not what the compiler compiles by default. So if we want to use the C99 standard, we have to ask for that, std equals C99. So that'll request the C99 standard of the language. And then the name of the source file you want to compile, for us, hello.c. And then if we just hit enter here, it would compile our program, but it would write it out to an executable named a.out. I don't want that. I want to pick the name of my program. So I'm going to say -o and then hello. And this will compile my program to a executable named hello. And now if you take a look, well, there's hello. That's my executable. That star isn't really part of the file name. I've just got my shell, so it prints stars at the end of names that are executable, so I can see which programs are executable. But that's what the compiler just wrote out. And if we want to run it, so this line right here compiles our program. If we want to run it, /hello should do that. The / says I want you to run a program in the current directory. And then just the name of the program that we just built, the program we want to run. And if we run it real fast, it prints out the words hello world. So we successfully compiled a C program and then we ran it. And that's how we're going to compile and run all of our programs. I'm going to go back to the slides. And the commands that we just looked at are right here at the bottom of this slide. So this is what we just ran to compile it, and here's how we just ran it. And like a good Hello World program, it prints out Hello World when we run it. I want to talk a little bit about what's in this program, and a lot of this stuff will either already be familiar to you or we can make good comparisons with Java. You'll notice we've got block comments here. We're using the Javadoc style way of writing, at least Javadoc block comments, starting with /** and //. And then inside those Javadoc comments, we can use the same kinds of tags that Javadoc supports. When Java was created, it stole a lot of good ideas from C. But this is one that went the other way. When they created the Java language, they came up with this neat way of building documentation into your source code. And C, or at least some development tools for C, have adopted the same conventions. So in C, you can use Javadoc style comments, and there are automated tools that will extract those and build HTML documentation for you. And our style guideline says what Javadoc style comments we're going to use. So every file is going to have a Javadoc style comment at the top with certain tags in it. Every function we write is going to have a Javadoc style comment in front of it with certain tags. You can see I've got an include stdio.h. That's kind of like a import. Sorry, my Java is a little bit rusty. That's a little bit like in Java if you're going to use certain features of the language. I'm saying that right, aren't I? It's import in Java to import certain language features, to import a class prefix. Am I saying that right? Package?
Yeah, that's right.
Okay, I apologize. My Java is rusty. I'm embarrassed that it's that bad. But in C++ or in C, include lets us talk about features of the language, or really parts of the language standard that we're going to use. And standard.io.h is called a header that defines, or at least describes, IO features of the language. Since we're going to print out some stuff at the bottom, we need that stuff. If you look down at the bottom, I've got this thing called main. And just like in Java, if you run a Java program, it starts at the main method. In C, it's not a main method. It's not part of a class. It's called a function. Instead of being hidden inside a class, it's just right there at what we'll call file scope, but it's doing the same job. If you write a C program, it's going to start running at whatever's inside the main function. So inside these two curly brackets is sort of the body of our program. The last thing we do before we exit is we return 0. In fact, in Java, main is always a void method. In C, it's always an int returning function. And that integer is what's called the exit status. In a C program, it returns a number once it's done running. And that says whether it's succeeded or failed. If the program returns a 0, that means it ran successfully. Anything else is interpreted as an error. That means something went wrong during the execution of our program. So we return 0 there at the bottom, meaning we succeeded. And then the only part left is this printf hello world. There we're calling a printf function. That's a lot like calling a method in Java, but in C, functions aren't inside classes. They're just a name with parameters you want to pass to them. So we don't have anything before this printf. There's no object or class dot printf. It's just plain old printf. Any string that you pass to printf just gets printed out on the terminal window on what we'll call standard output. So the string I want it to print is whatever's inside these double quotes. So just like Java, you specify a string by putting it in double quotes. By default, printf prints whatever text you want it to print, but it doesn't automatically print a new line at the end. So I put this \n at the very end of my string, so it won't just print hello world, but it'll end that output line and go down to the next line before it prints, say, my shell prompt for the next command. So whereas in Java, print line automatically prints a new line at the end, printf in C doesn't automatically do that for you. It's more like Java's, is it write and write line? I may have said that wrong a moment ago, for printing a line with a new line at the end and without a new line at the end. So in C, we just have printf for printing out whatever strings we want to print. We already covered most of this. When you run the compiler, here's kind of a template for how you might run it. I already explained this when I was typing in the compiler command before. So this is like the command we used to compile. And then once we had compiled it, we used /hello to run it. Questions about our first program at this point?
Actually, with void, I was wondering, or sorry, with main, can you
Yeah.
make it void, or is that a C++ thing?
I think you are permitted to have a void main. I think if you do, it's just going to return success by default.
Oh, okay.
We're never going to do that this semester, so
Mhm.
that's one reason I'm uncertain about that. I think there are a certain number of permissible type signatures for main. I think void main is okay, but I don't remember for certain about that. And one reason I don't remember is because I never do that. I always put the int.
Yeah. Someone else is asking, does the order of the options when compiling matter?
No. So yeah, this wall could go at the end. Same thing with this. I guess this -o, sorry, I'm pointing here, this -o and then the name of the output file, those have to be right next to each other. So you can think of this name as going with the -o, but order doesn't matter for any of the other options. So think of this one as coming in 2 parts, but the rest of these are just 1-part options. So it shouldn't matter. I usually type them this way, but if you put the standard C99 first, you'd get the same behavior. Anything else? All right, I got 5 minutes left and I've got 9 slides. In these 9 slides, I want to convince you that you already know a huge amount of C. Now, sure, you have to write your program as a bunch of functions instead of methods. But it starts at the same kind of place. It starts at a function named main. Inside that function, you can declare variables, and the variable declarations look a lot like Java variable declarations. You can declare variables with names just like you would in Java, and you can even give them initial values as you declare them. A lot of the same types are there. I've listed short, char, int, long, float, and double. C has all of those types. They may not be exactly the same size, but the same names we had in Java. Java has a byte and a Boolean, and C doesn't have those. But in C, we just use char instead of byte. It's the same size as a 1-byte character. And we're going to use a type named bool for true and false values. And it kind of does the same job as Boolean. So we've got a little bit of a difference in naming there. In Java, you're used to the operators I've listed here, plus, minus, times for arithmetic operations. Logical operations like and or, pre and post increment, and comparison operations like equal and less than. You're accustomed to the assignment operations like like equals and plus equals. C has all of those, so you can still use those same operators, along with a few others that we will learn about later. I listed those at the very bottom. You can use a single ampersand to do a job in C that Java doesn't really do. You can use star to mean some other things in C that Java doesn't have, and we'll learn about those later. But all the operators I listed there in that little table should work fine in C, just like they did in Java. If statements from Java work the same in C, and they've got the same syntax, and if you want to put else clauses on them, they work the same in C. For loops in C look like they do in Java. You can't use that colon syntax in C, but at least as of the C99 standard, you can declare variables right inside the for loop. The older version of the language didn't let you do that. You had to declare the variable beforehand. So that's a little reason I like the C99 standard. So for loops look a lot like they did in Java. While loops and do while loops are there just like they are in Java, and they work pretty much just like they did in Java. The switch statement is a little bit different. C has a switch statement, but it only works for integers. In Java, switch statements can work on strings, and you do have a switch in C. You just can't use it for switching based on the values of a string. For flow of control, C has break and continue statements. It's got its break statement is a little more restrictive, and it's got one super flow of control statement that most people hate that Java doesn't have. We'll learn about that a little bit later. But as far as break and continue, you can use some of the same tricks you're accustomed to in Java. In C, like I said, we don't get to write classes. So we build our program out of a bunch of functions, like this power function I wrote. A function can have a return type, just like a method from Java. It can take any number of parameters, each of which have types, just like in Java. But since it's not part of a class, to call a function, you just give it its name, like I'm doing down here at the bottom of my slide, and the values of the parameters inside parentheses after the name. And when you call the power function like this, 3.25 will get passed in as the value of x, and whatever j is plus 1 will get passed in as the value of p. Just like a method in Java, it'll compute all the statements in the body, and then whenever you do a return, whatever value you return will get returned as the value of the function. You can assign that to a variable if you want, just like you would have in Java. Like I said, these are kind of like methods from Java, but we call them functions in C, and since they're not part of classes, when we call them, we don't have to put anything in front of the name of the function. We just use the name of the function. In C, until we learn how to do this otherwise, functions have to be defined before you can call them. So a function like power has to be defined, and then a call has to be later in the same source file. And our last slide for today, one difference is C does not force you to initialize variables before you use them. This is usually a bad thing. In Java, if you wrote a piece of code like this where you made a variable called result, and then you used it without putting anything in result, the Java compiler won't even compile your code. The C compiler will, and result will just start out with whatever happens to be in memory when that variable gets made. So I usually say it'll start out containing whatever garbage was in the place where result is going to get stored, which means the behavior here, like if you back up here, I put an initial value in result. So this function will behave consistently. Here I didn't. So result will start out containing who knows what. It'll depend on your compiler and your execution environment, which means this function, who knows what it's going to return, because its return value depends on result. which means this is probably a bug, just a bug that the compiler won't detect for you. Java wouldn't let you do this, but this is something you can do in C. It's probably just something you don't want to do in C. Probably the most common source of errors early in the semester. So be careful about this. Be careful about declaring variables and then using them without ever actually putting a value in them. And it took us a couple of minutes extra, but that's the end of the material we were supposed to cover for today. Thanks for your attention. I'll go ahead and stop the recording at this point, but if you want to hang around and ask questions, I'm happy to take those as long as people are interested. Again, thanks for your attention. I'll see you on Monday. Remember, you've got an exercise and a quiz due before then. I'll see you then.
Professor, can I ask the class question?
Yeah, let me stop the recording.
All right.
How do I stop recording? Hang on.